So we're going to basically discuss how we sample and what sampling versus populations are and what the process or methodology of samplings is. And when we discuss methodology, in other words, how we're actually gathering the people that are in our study, the sample, this really is often the hidden part that is the most important part of a lot of data that we make decisions based on. In other words, whenever we're reading an article, it really goes into the methodology of how the data was collected. It simply gives us the information. It's one of the reasons that as consumers of data, we really want to have an understanding of how this can impact and the different methods that are used in order to determine what we're actually reading or understanding in a study. So let's move forward fairly quickly and discuss the various concepts and then the various methods that we can use when we're talking about gathering people into an actual study. So generalizability is what we're really talking about here. And the concept is, does the sample represent the population? And for that, we need to be talking also about what samples and populations are. And I'll talk about that in the next slide. But generalizability is, do the people studied represent the population of interest? And the population of interest is matters too. So when we talk about sample, we're talking about the people that we're actually gathering data from. And the population is everyone that we're going to draw a conclusion about. So for example, if we're interested in showing that a particular substance causes cancer, our population at that point is likely the world. We're looking at, does this substance cause cancer in people in general? In that case, our population is the world. And if we really wanted to say that we have evidence that suggests that this substance causes cancer, we would want a sample that represents that population. In other words, if the only people that were in our study were people from England, from the upper middle class that came into a hospital in London, and we found this result, that might give us some information about a particular ethnicity, a particular social economic status, a particular culture. It would be hard to generalize that to the entire world. However, if we were looking across multiple studies that looked at the same substance causing cancer in Japan, in China, in Thailand, in the United States, in South America, in Africa, in that case, we would also start to find that if we find that effect over and over and over again in different groups of people with different cultures, at different economic statuses, in different types of hospital settings, from the very rich to the very poor, we would have a lot better argument for generalizability. So you'll notice that my example here of when we have strong generalizability actually relied on multiple studies. It's very hard for a single study to truly get at generalizability if our population is people in general, the world. We're usually looking at multiple studies done across the world, and often what we'll see is what's called a meta-analysis that gathers all of the data from multiple studies to look for an overall effect. When we're also looking at generalizability, we want to think about some concerns, and that includes samples and settings. So the samples are who are the actual people, and this includes age, ethnicity, gender, culture. There's a lot of factors that become a part of that people samples. And the next one is situation, so the settings themselves. So where are the people actually coming from? Are we looking at government research institutes? Are we looking at people that self-selected into the studies? Again, what are those settings that are being involved? So again, the population is the group you're interested in studying. And of course, in my previous example, I talked about the world, but that population may not be the world. The population may be college students in the United States. It might be people in assisted living facilities in Germany. The question is that whenever we're doing a study, we do want to ask the question, what is that population? Who are we trying to, through this study, represent through our sample? Because knowing our population is going to guide how we gather our sample. The sample is a subset of that population, and these are the people that we actually gather data for. So we want to think about the two general ways that we can get samples: bias samples versus representational samples or representative samples. And there's multiple methods of both, and neither are necessarily wrong. Bias samples are usually much easier to get. They are less time intensive, they're less resource intensive, And getting a truly representational sample often can be quite problematic. So again, we have our population of interest, and we have two big subsets, representational samples and bias samples. And we're going to talk about each in detail. So if our population of interest, our bias sample is some types of people are systematically left out. That's simply the reality. And this can include purposeful sampling, convenient samples. So for example, if we do a study and our study is this class, that's a convenient sample. Self-selected samples, snowball samples, and quota sampling. And we'll talk about all of these in detail. We're then going to also look at representational samples. All members of the population of interest have an equal chance of being represented. Now, there are different techniques: simple random sampling, systematic sampling, oversampling, cluster sampling, and multi-stage sampling, and stratified random sampling. And again, we'll talk about each one of these in more detail. So let's talk about the gold standard, if you will, probabilistic sampling techniques. This is where we're actually being able to make a stronger argument of generalization. We've defined the population, and we're trying to make sure that we have a representational sample of that population. So the first one is simply random sampling. Simple random sampling means we've identified the population, we know everyone that's in it, and the way you get into the study is you are randomly selected to be in the study. Now, simple random sampling might sound like the ideal, but there's a problem here. How are we actually identifying the people? Do we actually have an entire list? So for example, if my population is a class, 65 students, that's pretty easy to simply randomly sample. I randomly determine from those 65, 10 people to be in my study, for instance. But let's say my random sample is the population of IU Bloomington or IU East. At that point, we now have to ask the question, do we actually have an entire list of everyone that's currently a student? How do we reach out to those students? Do we use emails? What if the student isn't checking their email? That's the process, that the further and the larger the population is from the actual researcher, the harder and harder it becomes to truly get a simple random sample. Because in order to do a simple random sample, a couple of things have to occur. Actually, three things, honestly. One, you have to actually know everyone that's in your population. Two, you have to come up with a method to reach out to the people that are randomly chosen for that population, that everyone will actually receive the message. And three, everyone that actually is randomly sampled has to say yes and take part in the study. If any of those things disappear, we start to run into issues where we probably are not truly doing simple random sampling. Cluster sampling simply means that we've identified a population, let's say, for example, the United States. And we're going to basically look at a list of every city of over 1,000 people. We're going to randomly select 10 of those cities, and then that becomes our sample. The argument can be made at that point through cluster sampling that we have indeed gotten to a random sample. Now, you can see that the smaller the sample, the less likely it's going to be representational. So for example, if I made a list of every city of over 1,000 people, and I had that list and it was trustable from the US Census, I then randomly selected 10 cities. What's the random chance that I actually get a large city? What's the random chance that they're all small cities? If they are all small cities, have I now basically created a sample where for the most part I'm getting urban versus rural populations? So again, cluster sampling is a way to try to get around some of the issues of true simple random sampling, but at the same time, it can be an issue as well. And population and again, resources and ability to contact people. Now, multi-stage sampling is where we actually break down things a little bit more simply, though in a more complex way. So again, if I was interested in the United States, what I might do is start with the 50 states. I then randomly select 10 of those states. Within each of those 10 states, I randomly select 10 cities. With each one of those cities, I randomly select 10 areas, let's say north, south, east, or west part of the city. And then from there, I randomly select 10 people. That would be a multi-stage sampling. Stratified random sampling is another method that we can look at this. And the stratified random sampling simply means that I am determining the demographics that I want to see. And at that point, I'm actually choosing a random selection of each group. So for example, Stratified random sampling might be that I know that I want that the population has 55% men and 45% female. Therefore, I'm going to randomly sample from my sample 45% female, 55% men. That's a stratified random sampling. Oversampling means that I know that there's certain populations that I want to make sure that I have representational data from, but are going to be harder to find. So I oversample them. So for example, looking at a stratified random sample, I might determine that a particular group that I'm interested in has a very small number in the overall population. So though why I spend a fair amount of time making sure that I have a stratified random sample of other ethnic groups or other groups based on various demographics, for that smaller group, I actually purposely double or triple the number of people that I'm trying to sample. Not necessarily because I'm trying to give them extra weight in the study, but I want to make sure that I just don't have one or two people, that I actually have enough people to make some conclusions from. And finally, systematic sampling simply is the suggestion that we are looking at again, we have a list, and from that list, we're going to take every 10th person. To make it systematic sampling and a probabilistic, we do have to randomly determine where we start. So for example, if I have 10,000 people, I put that in a random number generator, it generates the number 688. 688 is the very first person. But from that person, every 10th person is sampled. Then we have basically the bias sampling techniques. The most easy is, of course, convenience samples. And again, in this case, it's simply who we have access to. A lot of times in a lot of studies in psychology are convenient samples. For instance, people might be taking an introduction to psychology course that has a component where they have to participate in research in order to pass the class. In that case, that is definitely a convenient sample. Purposeful sampling means that I know that I'm not going to get an actual representational sample, but I want to make sure that I get people that I want in my study. So for instance, if I'm looking at people that are in assisted living homes, that'd be a purposeful sampling. I'm looking just at that group and I purposely go to an assisted living facility and try to get everyone as possible. So it's not necessarily that it's convenient for me to get this, but I've purposely chosen it. For example, in my actual master's thesis, I was interested in science fiction fans, which meant that it wasn't necessarily a convenient sample. It wasn't an easy thing for me to get. But what I did is I actually went to various science fiction conventions, set up a booth, often I had to pay for it, and asked people to participate in my study. That's purposeful sampling. Snowball sampling can actually be done where what we're looking at in snowball sampling is, again, it's usually going to be a harder to find population. So an example of how to take purposeful sampling into snowball sampling is if every person that participated in my study, I ask them, do you know anyone else that's in this subgroup, and can you recommend my study to them? So for instance, I start with one person. I get someone that actually fits the requirements for my study, and then I ask them, do you know other people that fit this description? And then if they come into my study, let's say I get 2 or 3 people, I ask them, and this is the snowballing idea. We're using our participants to find more participants. Self-selected sample is often what we find in medical research. People are selecting to be in the study because they've heard about it and they want to be involved. And finally, quota sampling is very similar to that stratified sampling we were talking about in the last slide. In this case, I'm taking every 10th person, I'm taking every 5th person, but I'm not randomizing where I start. I start with the first person that I actually have access to. And then 5 people later, I do the study again. 5 people later, I do the study again. That's quota sampling. So for the chapter assignment, you're needing to read a brief description. You're interested in studying the average price of books at your local Barnes & Noble. The store carries 20,000 titles, but you plan to only sample 500 books. You plan on selecting a sample of these 500 books, writing down the price of each book, and use the average price of those 500 books to estimate the average price of 20,000 books in the store. Based on this information, answer the following questions. What is the sample in this study? And what is the population? Hopefully that's fairly straightforward. I'm not going to give you the answer, but those numbers are in the actual description. How might you collect a simple random sampling of the book? So think about, you do have a list of all 20,000 titles. So how would you conduct a simple random sample? How might you construct a stratified random sample? Think about how our Barnes & Noble is set up. Are there various divisions within that? Are there various book types? would you want to make sure that you get a stratified random sample from each of those categories? How might you collect a convenience sample? So what would be the easiest way for you to get those 500 books? How might you collect a systematic random sample? So again, remember, the systematic random sample means that we're systematically going through and selecting every 10th, every 100th. So basically you would take 20,000, divide by 500 books, and that would tell you how many individual books or how many books you would have to skip over to get 500 out of that 20,000. Remember though that you do need to start randomly. And then might you collect a cluster sample of 500 books? This is the assignment that I'm wanting you to do. I'm wanting you to apply what you've learned from this lecture, what you've learned from the textbook, how you understand these various techniques, and then I want you to apply it to this particular assignment. So integrating external validity, what matters most? We do have to note that there is, in my opinion, basically a seesaw. The more external validity you have, in other words, the more generalizable it is, also the harder it is to actually get a true understanding. And what I mean by that is internal validity, the truthfulness of the study. So when we're looking at external validity, it matters most when we're talking about frequency claims. In other words, if I'm making a claim that in a population a set percentage exists of a particular attitude or a particular thought, then it is important that I get to generalizability, that my sample is representational of that population. This is very important, for example, in public opinion polling. When is a representational sample not a top priority? If I'm really focused on trying to get at effect, if I'm looking at does A cause B, I'm probably less concerned with external validity, and I'm more concerned with setting up internal validity, that I am certain of my finding within my sample. And finally, we do want to recognize that larger samples are not necessarily more representative, but may be statistically more accurate. And I'll talk about that a little bit in the next slide. So larger samples are not more representational. So just having a lot of people in your study does not mean you've done everything right methodologically. A convenience sample can be large. If I was looking at the university and there's 25,000 students and I got all 25,000 to give me data, that would be a large sample. That would be statistically internally validated. I could be fairly internal validity. I could definitely be certain of my findings within that sample. But if my population was college students across the United States or college students across the world, I would have to acknowledge that I have lost some generalizability. Now, what does increase with sample is our certainty of what we're finding. So for example, this is basically based on estimates in this table are based on a 50% polling result. In other words, I've actually gotten, for example, at the bottom here, 50 people to follow us to take a study. And within those 50 people, 25 people said yes, 25 people said no. At that case, I could say it's a 50-50 split. However, the reality is plus or minus 14. In other words, it could be as little as 36% said yes, while 74% said no, or 64% said no. As I increase the size of our sample, you'll notice that the plus or minus goes way down. If I've got 2,000 people in my study, and you'll notice most public opinion polls are between 1,000 and 2,000 for this very reason. If I say there's a 50-50 split, the reality is, at worst, there's a 48-52% split, one way or the other. If you ever heard the term margin of error, that often means that the polls are showing that people are within the margin of error. So for example, a poll might show that one person has 51% of the vote and one person has 49% of the vote. So by the poll's hard numbers, you'd say the person with 51% is going to win that election. However, the error, there was 2,000 people in that sample, is plus or minus 2%. That's within the margin of error. In other words, the 51 might actually be a 49, and the 49 might actually be a 51. It's likely that the person with the 51% is going to be the winner, but we don't know for certain. There's a margin of error. So again, when we're looking at large samples, we're looking at how much we can trust what we found in our sample. If we're trying to then make that conclusion that what we found in our sample we'd find in our population, that's not actually determined by sample size. That's determined by how did we gather that sample.